Mary Swarnalatha, working as Professor in Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the definitions and terminology on the characteristic function and moment generating function for single and multiple random variables. So, first the definition is define moment generating function of a random variable. So, the moment generating function of a random variable is nothing but it is a expectation of e power vx. So, for example, if x is a random variable, then the moment generating function of that random variable has been denoted by mx of v is equals to expectation or the statistical average of e power vx. So, it is called as what? The moment generating function of a single random variable x. And this moment generating function is used to calculate the moments of the origin. Next one is define characteristic function of a random variable. So what is the characteristic function of a random variable? The characteristic function of a random variable x has been defined as the expectation of e power j omega x, or else it is also called as what? The Fourier transform of the probability density function, or else we can define the characteristic function as what? The Fourier transform of the probability density function of that random variable x. So, what is the Fourier transform of the density function? Nothing but integration minus infinity fx of x into e power minus j omega x dx. So the characteristic function of the random variable x is nothing but the Fourier transform of the probability density function of that random variable. So what is the Fourier transform of a signal x of t? It's nothing but integration minus infinity x of t into e power minus j omega t dt. Similarly, what is the Fourier transform of the probability density function of the random variable x? How can you obtain? Here integration minus infinity fx of x into e power minus j omega x dx. But in place of minus, you get here for characteristic function, you have to take the positive sign. So integration minus infinity fx of x into e power j omega x dx. Therefore, you can define the characteristic function of a random variable as the Fourier transform of the probability density function, or else you can define the characteristic function as the expectation of e power j omega x. Next one is, what are the properties of the characteristic function? The characteristic function of any real valued random variable is always exists. That is the first property of the characteristic function. If you take any random variable, then its characteristic function will always exist if its Fourier transform exists. So this is the property of the characteristic function. And next one is, what is the application of the characteristic function? The characteristic function is used to find out the moments about the origin of a random variable. So what are the moments about the origin of a random variable? Nothing but what? M suffix n. That is nothing but what? Expectation of x power n. Therefore, if you know the moments, you can calculate the mean, variance, skew, etc. Therefore, the characteristic function are used to calculate what? The moments about the origin of a random variable. Next one is, what is the application of moment generating function? So like we have used the characteristic function to calculate the moments about the origin, in the similar manner you can use the moment generating function also to calculate the moments about the origin. So these are the applications of the moment generating function and the characteristic function. So next one is, define joint moments about the origin. So previously we have seen the moment, if x is a random variable, then what is nth moment has been defined as what? Expectation of x power n. Now here you are taking a single random variable. For example, I have two random variables, then I'll call it as what? Joint. If I have more than one random variable, it is called as joint density function, joint distribution function. So similarly, joint moments. So if you have more than one random variable, nothing but 2, 3 and so on n random variables, then it is called as what? Joint moments about the origin. Now, if you take two random variables x and y, then the joint moments about the origin has been represented by what? M suffix n, or else here x power m into m suffix n comma k. So here you can write as what? Expectation of x power n into y power k. Just in place of m I have taken n, in place of n I have taken as what? K. Then expectation of x power n into y power k. So this is called as what? The joint moments about the origin. So if you take two random variables x and y, then the joint moments about the origin is equals to what? Expectation of x power n into y power k. And what is the order of the moments here? N plus k. Here what is the order of the moments? N. So this is nothing but joint moments about the origin. And define central moments. So central moments nothing but what? Mu m comma n is nothing but what? Expectation of x minus x bar. Here x bar is nothing but mu only. Power m into y minus y bar power n. Here y bar nothing but what? The mean of the random variable y, and here mu nothing but the mean of the random variable x. So this is called as what? The joint moments about the origin. It is also called as what? The joint central moments. And what is the order of the moments is equals here m plus n. The order of the moments here is nothing but m plus n. So next one is define joint characteristic function. So previously we have seen the characteristic function for a single random variable. So pi x of omega, or else you can denote by cx of omega also, is equals to what? Expectation of p power j omega x, or else you will call it as what? The Fourier transform of the probability density function of that random variable. This is for what? Single random variable. Now, if you have more than one random variable, if you have what? More than one random variable, it is called as what? The joint characteristic function. For example, I have taken two random variables x and y. Then the joint characteristic function of the two random variables has been given by pi xy of omega 1 comma omega 2 is equals to expectation of e power j omega 1x into e power j omega 2y. Now we can write this as what? Expectation of e power j omega 1x plus j omega 2y. So this is called as what? The joint characteristic function of two random variables x and y. Next one is, in the similar manner, you can define the joint moment generating function also. So if you have a single random variable, it is called as what? Moment generating function, and it is written by what? mx of v is equals to what? Expectation of e power v into x. Now, joint moment generating function nothing but having more than one random variable. So, for example, x and y are two random variables. Then it is called as what? The joint moment generating function. And it is given by mx y of v1 comma v2 is equals to expectation of e power v1x into expectation of e power v2y. Rs can write this as what? Expectation of e power v1x plus v2 into y. So this is the definition of what? The joint moment generating function of two random variables x and y. Next one is define covariance. So what is a covariance? So we have seen the variance, and what is the variance of random variable x? Sigma x square is nothing but what? Expectation of x minus x bar whole square, which is called as what? Variance of a random variable x. Now, if you have more than one random variable, for example, if you have two random variables x and y, then the covariance between these two random variables is nothing but cxy, or else it is called as what? Sigma xy has been defined as what? How they are defined, how their deviation from their expected value, nothing but mean, nothing but expectation of x minus x bar into y minus y bar. So this is called as what? The covariance of two random variables x and y. So if you simplify this, you get as what? Expectation of xy minus x bar into y bar. How they are deviated from their individual expected values. This expectation is called as what? The covariance. It is nothing but what? The second order central movement about the origin, where m equals to 1 and n equals to 1, which is called as what? The covariance of two random variables. So nothing but second order joint central movements with m equals to 1 and n equals to 1. So it is nothing but the expectation of the deviations from the individual expected values. Next, define orthogonality. For example, if two random variables x and y are orthogonal, then what is the condition? The expectation of product of those two random variables is equals to 0. Then you can say that the two random variables are orthogonal random variables. Next one is define correlation coefficient. So previously we have seen the covariance. Now what is a correlation coefficient? The correlation coefficient is nothing but it is a statistical measure that will calculate the strength of the relationship between the movements of the two random variables. So you can mathematically define this correlation coefficient by rho. So rho xy simply represented by rho is equals to cxy. It is a ratio of the what? The covariance to the product of their standard deviations. So this is called as what? Correlation coefficient of two random variables x and y. So what is cxy here? Cxy is nothing but what? Covariance of the two random variables. And what is sigma x and sigma y? They are nothing but what? Standard deviation of the two random variables x and y. And moreover, always correlation coefficient will be between from -1 to 1. So next one is define zeroth order joint moments about the origin. So if you have two random variables x and y, then how do you represent? So these are the two random variables. Then how can you define the joint moments about the origin of the two random variables x and y is nothing but what? M n k is nothing but what? Expectation of x power n into y power k. Now we have to calculate what? Zeroth order. So zeroth order nothing but what? What is order here? Is equals to n plus k. So zeroth order is nothing but what? You have to take n plus k equals to 0. So when can you apply n plus k equals to 0? N equals to 0 and k equals to 0. Therefore m0 0 is nothing but expectation of x power 0 into y power 0. Nothing but expectation of 1. What is expectation of any constant? The constant itself. Therefore, what is the zeroth order moments about the origin? Value is equals to what? 1. Nothing but unity. Next one is define order 1 joint moments about the origin. So what is order 1 is nothing but n plus k is equals to 1. So you can take n equals to 0, k equals to 1. This is first case. Or else you can take n equals to 1 and k equals to 0. Then what is m0? 1 is nothing but expectation of x power 0 into y power 1. Nothing but what? Expectation of y. Nothing but y bar. Or as mu y. Mean. Which is called as what? Mean of y. Similarly, what is second case? You can take n equals to 1, k equals 0. Nothing but expectation of x power 1 into y power 0. Nothing but what? Expectation of x. So what is expectation of x is called as what? X bar, or it is also called as mu x. So it's nothing but what? The mean of the random variable x. Therefore, the first order joint moments about the origin gives the means of the two random variables x and y. If n equals to 1 and k equals 0, you will get the mean of x. And if n equals 0 and k equals 1, you will get the mean of y. Next one is define second order joint moments about the origin. So second order means what is order here? n plus k is equals to 2. So if for n plus k equals to 2, how many values are going to get? The first case is what? N equals to 2, k equals to 0. Second case, n equals to 0 and k equals to 2. And third case, n equals to 1 and k equals to 1. Now, if you go for first case, then what can happen here? M20. What is M20 equals to? Expectation of x square into y power nothing but u of x square. This is called as what? Mean square value of the random variable x. Similarly, what is M0 comma 2 equals to? Expectation of x power 0 into y square. Nothing but what? It is a mean square value of the random variable y. And third case is n is 1, k is 1. Then what is m1 comma 1 is equals to expectation of x power 1 into y power 1. Nothing but what? Expectation of x into y. So these are called as what? The second order joint moments about the origin. If 2 and k equals 0, that gives a mean square value of random variable x. If n0 and k equals to 2, that gives a mean square value of random variable y. If m is 1 and k is 1, it is called as nothing but u of xy, which is called as actually correlation. Correlation between the two random variables x and y. Next, define third order joint moments about the origin. Third order means here n plus k equals to 3. So n plus k equals 3 means what is the first case? N equals to 3 and k equals to 0. Second case, n equals to 0 and k equals to 3. Third case, n equals to 2 and k equals to 1. Fourth case, n equals to 1 and k equals to 2. So the totally they have how many possibilities? Having 4 possibilities. So what is the first one? N equals 3, k equals 0, nothing but m3 comma 0 is equals to what? Expectation of x cube. And what is m0 comma 3 equals to? Expectation of y cube. Then m2 comma 1 is equals to expectation of x square and y power 1. And n1 k equals 2 means m1 comma 2 equals to expectation of x into y square. So these are called as what? The third order joint moments about the origin. And the similar manner we can define for central moments also. What is the first here definition? Define zeroth order joint central moments. So what is the joint central moment? Nothing but mu n comma k equals to what? Expectation of x minus x bar power n into y minus y bar power k. So what do you want here? Zeroth order. What is order here? Order equals to n plus k. So zeroth order means here n plus k equals 0. It means n value 0, k value 0. So if you substitute n equals 0 and k equals 0, you will get expectation of 1. So what is the expectation of 1? 1. Therefore, the zeroth order joint central moment is equals to unity. Next one, define first order joint central moments. So first order means n plus k equals to 1. It means here n equals to 1 and k equals to 0. Or else you can take n equals to 1 and k equals 0. Second case, so n equals to 1 and k equals 0. Second case can take n equals 0 and k equals to 1. So here expectation of x minus x bar power 1 into y minus y bar power 0. Nothing but expectation of x minus x bar, because y minus y bar power 0 equals to 1. Whereas here, what is the case here? This is n equals to 0 and here k equals to 1. So this is called as what? The first order joint central moments. And next one is define second order joint central moments. So what is order here? N plus k equals to 2. It means what is the first case you are taking? N equals to 1 and k equals to 1 here. So n equals to 1 and k equals to 1. And then n equals to 2 and k equals to 0. Or else n equals to 0 and k equals to 2. Totally 3 cases. So n equals to 1 and k equals to 1. Second case, n equals to 2 and k equals to 0. Third case, n equals to 0 and k equals to 2. So this is called as what? The second order central moments about the origin. So if n equals to 1 and k equals to 1, it is called as what? Covariance. Nothing but what? expectation of x minus x bar into y minus y bar, or as expectation of x minus mu x into mu y. So this is called as what? Covariance. If n equals to 2 and k equals 0, is nothing but what? The variance of the random variable x. Nothing but what? Varies sigma x square. And if n equals 0 and k equals 2 is called as nothing but what? Variance of the random variable y. So for the second order joint central moments, we are going to obtain the covariance and the variance of the two random variables x and y. Next one is define joint central moments. So the joint moment about the mean is nothing but what? Joint central moment. Next one is define marginal characteristic function of the random variable x. So what is a joint characteristic function of the two random variables x and y? Nothing but what? Pi xy of omega 1 comma omega 2 is nothing but what? Expectation of e power j omega 1x into e power j omega 2 y. Or else you can write this as like this. So expectation of e power j omega 1x. If you take j as common, then get plus omega 2 into y. Now, how can you obtain the marginal characteristic function of the random variable x? By keeping omega 2 equals 0. So in this equation, substitute omega 2 equals 0. Then what can you obtain here? Pi xy of omega 1 comma 0 is nothing but expectation of e power j omega 1 x, and here omega 2 equals 0. Therefore, this is called as what? The marginal characteristic function of the random variable x. And the similar manner, what is the marginal characteristic function of the random variable y? By keeping omega 1 equals 0 in the joint characteristic function, then you can obtain the marginal characteristic function of the random variable y. Next one is define marginal moment genetic function of the random variable x. So for two random variables x and y, so what is the joint moment genetic function? Nothing but mxy of v1 comma v2 is nothing but expectation of e power v1x into e power v2y. Or else you can write this as expectation of e power v1x plus v2y. Now, if you want the marginal moment function of the random variable x, we have to keep v2 equals to 0 here. So substitute here v2 equals 0. Then what can you obtain here? Mxy of v1 comma 0 is equals to expectation of e power v1 into x. So this is called as what? The marginal moment genetic function of the random variable x. So similarly, you can define the marginal moment function of the random variable. How can you obtain here? In the joint moment function, if you substitute v1 equals 0, then you can obtain the marginal moment function of random variable y. So in this lecture, we have discussed about the characteristic function, moment function, and the characteristic function, moment function are used to calculate the moments about the origin. So we have seen the moments about the origin, joint moments about the origin, joint central moments, which is also called as what? The moments about the mean. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.